Hey everyone, this is Chris Whitney, the Crane Man, here to talk to you this morning a little bit about how to do an overhead crane measurement. The purpose of this video is to give you the tools that you need in order to measure overhead cranes without having one of the crane specialists come out with you. This will allow you to work on projects on your own and ultimately be more successful in your crane sales. The fundamentals of this process are extremely easy. I'm just here to help you be more successful. So a couple tools that I'm going to use in order to help measure out this system is measuring tape. Typically a good 25 to 30 foot tape is perfectly fine. Also, handy dandy laser. You can pick these up at Lowe's or Home Depot. A cheap one is typically $65 to $70. You can get more expensive, better ones that shoot longer distances for $130 to $150. So that is basically it. You take your paper and your pen, you're good to go. So what we're going to do is we're going to go through the process of measuring out a system. So first we're going to start measuring the span of the crane. And then we'll move into the runway in the event that you need to provide a runway with the crane system. We'll also measure out the building clearances so that we can accurately determine where on this crane system our hook is going to land at its highest point. And then from there, we'll talk a little bit about crane duty cycles. That way you've got enough information that you can go in and talk with your client and be the knowledgeable salesperson that you are. So when you first walk into a client's facility, you're going to walk in and you're going to say, hey, look, I've got an existing runway here already. So I know that my crane is going to be going on an existing runway. From there, we're going to take the opportunity to get any measurements we can for the existing runway. That'll allow you to get back with your engineering team and tell them this is what they have currently in place. Things that we're going to look at are rail size, runway beam size, how often the runway is supported, as well as the runway electrification. All right, so we've walked into a facility. They have an existing runway where their new crane is going to be going. So here we have the opportunity to actually get measurements off of the runway beam. You won't always have the easiest access to it, but if they've got a lift or a mezzanine like we're standing on here, you'll be able to measure your runway beam so that engineering knows can be taken by the runway. So what we're going to do, you've got your runway beam. This particular runway beam has a cap channel on it. So we're going to measure all of that in order to get the information back to engineering. So to measure the runway height is as easy as running your tape measure up to the top. So here we have a 24-inch runway beam. After that, you also want to check your flange width. And we are at 9 1/8 of an inch. And also, since we've got it at the end of the runway, we can measure our flange thickness as well. And it is 3/4 of an inch. So, we've got the dimensions of our runway beam. Now we want to look at the cap channel as well. Our width, it's a 12-inch cap channel. Measure your toe, just 3 inches. And then you can also get the thickness of the cap as well. And it is a 1/4 inch. So again, that's the information that you need to get in order to make sure that engineering has the information they need. While we're up here, we can also measure out what our runway rail size is. That way, our wheels will be sized properly so that we don't have to do any kind of rail changes or wheel changes after the fact. So here, it's as easy as measuring the head width, which is right here, and also the height. So, this rail is 3.5 inches tall, and our head width is 1 3/4 inches. Again, those dimensions will allow engineering to look at the rail sizing chart and determine what size rail that the client has in their facility. When I'm taking these measurements, I always have a book and a pen in my hand. So I'm taking all these measurements down. If I have the opportunity that somebody's there with me from Mazzello, a crane technician or another sales specialist, I've got them taking notes as well. That way we can compare everything at the end. Another thing you also want to look at is the runway electrification. As you can see here, the existing runway electrification has 3 bars. That is all 3 phases of your electrification. Now, NEC codes have changed and now require a ground bar is added to any runway that has any new crane, hoist, or runway extension made to it. Basically, any major modification to a crane system that has only 3 bars needs to have a ground bar added. That can be done as easy as extending the bracket that holds the conductor bar and adding the ground bar. In addition, we'll also need to wire up a ground collector to any existing crane that is on that runway. All right, so now what we're going to do is we're going to measure span across the bay. That'll allow us to determine what our span for the crane is going to be. Basically, you're going to take your handy dandy laser again. You're going to place it flush with the runway or building support. From there, you're just going to hit your measure button. So you have a span of 48 and roughly 9 inches. This will give you a readout of what your span is. We're showing right now we've got about a 48 and 10 inch foot span. On this particular runway, our span isn't going to be exactly 48 foot 10, and that's due to the fact that there are haunches that come off the building support. Basically, your runway beam is not sitting on top of the building column, it's on the haunch. So you want to take a look, and you can eyeball it, take a look at how far off the building column the center line of your runway is. That again will allow you to get the accurate runway. So here's what I'm talking about when I say building haunch. So again, your runway beam is not sitting directly on top of the column, it's cantilevered off on this haunch. One thing you want to make sure is that you're getting around the correct measurement. After an order is received, we put together approval drawing and actually can get accurate measurements of the span by running a tape or a laser across at the runway level. But this gets you enough information to get an accurate quote. All right, so next we're going to measure the runway support centers. This will allow engineering to take a look at that runway beam that we measured previously, find out how long its long the support centers are, and then in turn check the beam to make sure it's going to work. Again, this isn't something that we take into account for pricing up the system, but we can make a recommendation based on our expertise that the runway beam is or isn't going to support the runway with the new crane on it. So what I'm going to do is I'm going to measure from the web of this runway column to the web of the next column down. Again, it'll be same as measuring your span. You take your handy dandy laser and you can make those measurements. To put it flush with the web of the column, you want to make sure you take a couple shots, make sure that everything is the same. We're roughly 39 feet in between building supports. If you remember, we were able to measure a runway beam height because we had a mezzanine to stand on or a lift to go up and measure the runway. In the event you don't have that, you can get some rough measurements as to what you were working with on the existing runway. So again, you take your handy dandy laser, you place it on the floor, you shoot to the bottom of the runway beam, and then you can hit the inside of the tap channel, which gives you what your height of your runway beam is. So I'm going to do that real quick just to give you an idea of what I'm talking about. So again, you want to be flush with the floor. Okay, so the bottom of our runway beam is 17.4 feet. You can do the calculations afterwards to get your inches out of it. So now what I'm going to do, we've got a cap channel on this runway beam. I'm going to shoot the laser from the floor to the bottom of the cap channel. That, minus what we had already measured, will give us what our runway beam height is. (19.4 feet. Subtract that by the 17.4 feet, you've got a 24-inch runway beam. So what we're going to do now is measure our building clearances in order to make sure that we've got all the space we need to fit our new crane in. With a double girder crane or a single girder crane, you're going to want to know what kind of clearances you have. We've already measured what our runway beam height is to the bottom and also to the underside of the cap channel, as well as our rail height. So we have an idea already of what the floor to the top of our rail dimension is. Now what we need to get is what our floor to the clear height is, so that we can make sure that we are not going to hit any building obstruction. So what I'm going to do, handy dandy laser again, I'm going to take a look at a couple clearance issues we may have. We've got a pipe that looks like a water pipe running across the bay, as well as the building support, and some other little smaller water or gas pipes running through. So we're going to take a couple of those dimensions and get some clearance information. So again, you want to make sure that your laser's flat on the floor. We're going to shoot the water pipe and then also the building headers. So we're at 22.9 feet. Now let's take a look at what our building header is. So basically what we can discern from this is our water pipe is actually lower than our building support. So that's going to be our clearance. Now, when we measure out where our crane window is, we're going to take from the top of that rail to the underside of that water pipe. Now we have to take into account the 3-inch required OSHA clearance from the top of our crane or our hoist to the water pipe. When looking at a double girder versus a single girder crane, if hook height is a paramount piece that the customer requires, you're going to want to make sure that they know that a double girder crane, while it's more expensive, can get you better hook height because your hoist is riding on top of the girders as opposed to below on a single girder crane. So you'll get better hook height, but again, it's not as cost effective as a single girder crane. All right, so again, guys, just a couple final keys that you need to make sure that you touch on when you're visiting with your client. Duty cycle, duty cycle, duty cycle. You need to know how many lifts per hour and at what capacity they're going to be lifting it. If they have a crane that they only want a 5-ton capacity for, and they're taking a 5-ton lift and making 5 to 10 lifts per hour, you're going to be chewing up a lot of the duty cycle on that crane. Motor start stops per hour are another thing, and it's going to affect your bearing life. So if you guys are looking at, let's say, a 10-ton crane, and most of their lifts are only going to be at 4 to 5 tons, that's only 50% of the crane capacity. So you can start looking at a little bit lighter duty cycle. But again, if you're looking at multiple capacity lifts multiple times per hour throughout an entire day, or even a 24-hour period of time, you really need to start looking at the crane duty cycle and making sure that we're providing them the components, because the estimators are only as smart as the information that they're given from the field. Another thing, again, as you're looking at a crane bay, you want to look at the space. Where is the crane going to be delivered through? How much space is the installer going to have to move through a plant? I've been in different plants where you've got to go from one side to the other with a crane hanging off of a IC80 lift, and there's no room to get through. So how is our installer going to know that if we don't tell them? You want to make sure that you're getting all of the information possible. Timeline, when we're going to be able to do the installation. Is it going to be something where they want us in their second or third shift when production isn't as high, or there's nobody there? They don't, customers don't want us to impede on their production always. Again, there's a cost associated with that. So the more you know, the more our estimators know, and even the more your client knows, everybody is going to come out of this with a win-win. So thank you guys again. I appreciate your time. Good luck measuring your crane, and please don't hesitate to give me a call if you've got any questions. We'll see you soon.